Okay, so this is the do now problem for lesson 8 on further identities. You're asked to prove that for the triangle given, a over the sine of a in that triangle is equivalent to b over the sine of b. And some of you may recognize that expression from the sine rule stuff that you did last year. And if you did manage to show that relationship last year, maybe you'll remember it and write that down now. But if you didn't, how would you go about doing this? I would look at an expression like that and say, well, what's the thing that's most complicated about this expression? It's the sign bits. One is that they are in themselves complicated because they're trig functions, and B, the extra bit is because they're in the denominator of that fraction. So there are a couple of things we need to tidy up to see whether or not we can make those two sides to this equivalent expression equal. So let's look at the left-hand side first. All right, so we've got on the left-hand side, we've got a divided by sine a. So the first thing we're going to do is just write that down. So we've got left-hand side is little a divided by the sine of the angle A, which is written as a capital. And the first thing I want to do is ask myself, can I simplify that expression? Can I get rid of the trig function at the bottom there and rewrite it as a trig ratio? So I'm looking at that triangle, and I notice that the vertical height of the triangle actually splits that up into two right angle triangles, which then allows us to work out those trig ratios. So sine A is essentially, if we look at, this is the angle A here, the sine of A is equal to the opposite A, which is h, divided by the hypotenuse of that large right angle triangle, which is going to be b. So we can rewrite sine of a as being h divided by b. So I'm going to rewrite the left hand side as being a at the top. I haven't done anything to that. And we're going to divide it by the opposite, which is h, over the hypotenuse, which is b. All right, so we've replaced the trig function for the angle a, and we've rewritten it using the equivalent trig ratio, which is h over b. And then we can simplify that and say, well, that's a pretty awful looking fraction, so we're going to bring that b up to the numerator. So that expression is now ab divided by h, and that is probably the simplest form for the left hand side. We've got a product of two sides in our numerator, and we're dividing that by another side in the denominator. So we'll leave that for the time being. That looks pretty simple. And what we're going to do now is work on the right hand side and see whether or not we can reduce that down to products and ratios of sides as well. So the right hand side was b over sine of b. And just like we did for the left-hand side, we will rewrite sine of b as a trig ratio. So angle b is the angle on the bottom right-hand corner of that triangle, which I've marked. The sine of b is opposite, which is again h, divided by the hypotenuse, which in this case here is a. So we're looking at the right-hand right triangle. All right, so h divided by a. So let's just do that. So we're going to say that the right-hand side is b. We haven't done anything with the b. Sine of b is h, the opposite side of the angle b, divided by the hypotenuse of that right angle triangle, which is a. And just like we did for the left-hand side, we will tidy that up. We'll bring the a up to the numerator. So that's going to be b times a, which is ab. And we're dividing that by h. And there you go. All right, so we've got two equivalent expressions. So all we're going to do now is, for this thing here, I'll just squeeze it in here on the right of that. Say, well, that's equal to the left-hand side, which we just calculated a few moments ago. Done.